Good afternoon, everyone who's here so far. We'll just give everybody a couple more minutes to arrive. Good afternoon and welcome, everyone. I'm happy to welcome you to our fourth seminar in our series organized by the Netherlands Astronomy Equity and Inclusion Committee. And we're very glad to have with us today Dr. Nic Bonne from the University of Portsmouth. He's originally from Australia and is a vision impaired astronomer with a background in galaxy research. He works in the UK as a public engagement and outreach fellow and in the Portsmouth Institute of Cosmology and Gravitation. Dr. Bonne is co-founder of and currently leads the Tactile Universe public engagement project, developing resources and activities to help vision impaired students across the UK and internationally access current topics in astronomy. He also consults on a number of vision impaired accessible projects nationally and internationally. So very happy to welcome Nic here and looking forward to this talk today. We will also have plenty of time at the end for questions and discussion. You can feel free at any time to post them in the chat and we'll communicate them from there, or you can speak up at the end. And so without further ado, I'll hand over to Nic.
Thanks so much for the introduction, Jake. And it's an absolute pleasure to be here talking today. So I'm just going to share my screen. I'm also going to turn my camera off because I have to get quite close to my screen to see what I'm doing, and you're going to be staring at my forehead for most of the presentation otherwise. Let's see. Okay, so I'm here today to talk to you about the Tactile Universe project, but I thought to put that project into context, it was important to introduce myself first and talk about my road to becoming an astronomer as somebody with a vision impairment. Okay, so I think you'd all probably agree that astronomy is, at least traditionally, a really, really visual subject. So it's something, when we talk about it, it conjures images that we've seen in the media. We think about those beautiful pictures of galaxies, of nebulae, of planets. When you say astronomy to sort of the average person out in the street, they'll imagine an astronomer physically looking through a telescope using their eyes. So there are all these really visual connotations that go along with astronomy. But also the way that we study astronomy, the way that we study the universe is also really, really visual in nature. And for all of those reasons, it makes astronomy a topic that can be really difficult to access for people with blindness or vision impairments, just because of that really, really visual aspect. So as Jake said in the introduction, so I'm an astronomer and a science communicator with a PhD that focused on studying galaxies in our local part of the universe. So that's sort of my research background. So I was born with my vision impairment. I was born 3 months premature. So basically my eyes were damaged by the oxygen that kept me alive. But it means that I've had my whole life to get used to my vision impairment. But even as a young kid, so at the age of 5, I had pretty much decided that I wanted to become an astronomer because I just found space fascinating. And that was minus all of that really beautiful visual stuff. So I could see some of that if I put my head really close to things, if I sat with my head right up against the television screen. I could see beautiful pictures of space, but really it was the idea of space, the idea that space is so vast, the idea that there's so many questions that as astronomers and as human beings we're yet to answer. That was really what hooked me, what got me excited about astronomy. And so I think I was also quite lucky in that nobody ever stopped me and said, but Nic, you're blind. Why do you want to do astronomy? It's going to be really, really difficult. And so I was able to hang on to that dream, and I was able to go through my schooling, go through my university degree, do everything I needed to do to try and become an astronomer. It wasn't always particularly easy though. So there was a definite lack of accessible resources. And oftentimes my teachers and I found ourselves thinking up our own ways to describe things or to help convey ideas that I would understand just because they were so visual in nature. But there weren't really things that we could download or that we could access that were going to be particularly helpful for that. And I may be a doctor now, but it definitely wasn't an easy process to get to that point. So I actually quit my first PhD. So I went straight from my university studies into a PhD. I chose a really, really visual topic to study. But most importantly, I stopped asking for help and I just tried to muddle along and do everything the same way that everyone else was doing things. And that actually made things really difficult for me. And it got to the point where I'd gotten so bad at asking for help, I got really anxious and depressed. And I ended up quitting that first shot at a PhD. And so I went away. I thought about what had gone wrong. I got a lot of help from other people as well. And I sort of reassessed myself and how I dealt with issues like that. I was lucky then that I actually got into contact with some people from my old university, and they said, hey, why don't you come back? Why don't you have another shot, see whether you like studying astronomy again? And so I went back, I started my PhD from scratch, and this second time I got all the way through. Definitely the second time round, what I studied was a lot less visual. So I studied local galaxy populations. I studied a sample of around about 13,000 galaxies in our sort of part of the universe. A lot of that study involved, though, compiling different data sets. So bringing together all of the different galaxy catalogs, compiling information on galaxy size, galaxy mass, galaxy color, galaxy morphology, all of the stuff that we can represent using numbers rather than sort of actually sitting down and looking at physical images. But even so, as scientists, we present so much of our work in the form of plots. So we plot our data, we show plots to other scientists to sort of get our ideas across. And so I had to work out ways to make plots that I could actually see. And I started off making plots that everyone else could see that were just terrible. Somebody actually pulled me aside at one point and said, Nic, can you actually see what you're plotting, what you're producing here? And I said, no. And they said, well, why don't you do something about that? And so you can see in the example plot on the left here, so this is a galaxy luminosity function. It's basically a histogram that's showing us the distribution of different galaxy masses or galaxy luminosities. What you'll notice, though, is all of my axes are really, really bold. All of my text is really big and really bold. I've deliberately chosen really distinct symbols for different data sets. So I've done all of this stuff to make this plot easier for me to see, but in doing this, I've also made this plot easier for other people to see as well. So it took me a while to work out what worked for me, what changes I needed to make to allow me to do astronomy well and to communicate my science with other people. Having said that, though, even though I was mostly dealing with big sets of numbers, with data, I did have to fall back on the images that data was based on. So on the left here, I've got an example of 4 SDSS galaxy images, so Sloan Digital Sky Survey. And I can't see these very well, but occasionally I'd have to look at images like these and make sure that my morphological information or my color information was correct. So the numbers in my catalog actually matched up with what these images look like. And oftentimes I would have to turn to my office mates, the people sitting beside me in my office, and say, excuse me, could you help me? I can't tell whether this is actually a spiral galaxy or whether it's actually got any blue starlight or whether it's completely red. So I found that side of things really, really complicated. And it wasn't until I moved to the UK, so my wife got a job at the University of Portsmouth as a researcher, and I followed her over here, over to the UK from Australia. And somebody said, okay, so you like public engagement. Why don't you think about doing that as a job? But also, what kinds of things might you be able to do to help other people with vision impairments learn about astronomy or get excited about astronomy? And in particular, what kinds of things would have made it easier for you? And so that's where the Tactile Universe comes in. So the Tactile Universe is a project that was founded in 2016 with a small amount of money that was given to us by the Southeast Physics Network in the UK. So they gave us a small grant to basically run a pilot for half a year to come up with some ideas that we could communicate, in particular galaxies research, to people with vision impairments. And as that project evolved, we actually shifted our focus slightly to concentrate on younger school students. So we wanted to try and inspire and I guess engage with younger people, get them excited about science, show them that something like astronomy would be accessible to them even if they have vision impairments. Okay, so the reason we focused or decided to focus on younger people was so it's actually based on a lot of research that's been going on in the UK, in the US, in Europe, that basically points to engagements with young people being really, really crucial to those young people developing a healthy attitude towards science, to developing enthusiasm towards science, and then potentially going on to choose science as a career. So the idea is that you want to engage with people when they're young, before other people in their lives. So say other people at their school, like their friends or their teachers or their parents or their grandparents or their uncles and aunties, before anyone else has a chance to say, oh, you shouldn't do science, it's stupid. So when other people say things like that to young people, it can really influence the way that they think, and they can start to believe that idea that something like that science is stupid. So if you can have positive interactions with students when they're young, show them that STEM, that science, that physics, that astronomy, things like that are actually exciting and something that they can be interested in, you can sort of counter that negative influence that other people in their lives might have. And it all leads into this idea of science capital. So science capital is basically the sum of somebody's investment in science. It has to do with how often they think about science, how often they engage with science, how often they do things like go to museums and learn about science. And so the idea is that you want to make sure that people's science capital is high by sort of engaging with them when they're young and continuing to engage with them over and over again. Because if you repeat the message that science is good, that message will stick around for longer. Okay. So through the Tactile Universe, the main things that we want to try and achieve are to develop and share multisensory resources for learning and research, along with the support needed for people to actually use those resources. So we don't just want to produce those resources and then hope that people can use them. We want to make sure that we're supporting people, showing them how to use those resources and helping them use those resources effectively. We also want to help science communicators learn how they can make what they're doing more accessible. So turn their science communication into more accessible science communication. And we also want to demonstrate that accessibility helps everybody. So I'm sure most of you probably know this already, but even if you make something accessible for a particular group of people initially, it will almost always end up working better for everybody who then comes into contact with that thing. So web accessibility is a really good example. By making the internet more accessible to diverse groups, the internet becomes more accessible for absolutely everybody. And so this is sort of the main goal of the Tactile Universe. And I'm going to go over how we are trying to achieve all of these goals. So here I have a picture of a typical galaxy. So this is the Hubble image of the Whirlpool galaxy, or Messier 51. And looking at this, you can see there's a lot of detail. So there's all of this beautiful sort of feathering in the arms. You can see the spiral arms. You can see the gas lanes, or the dust lanes rather, running through the arms. And you can see the companion galaxy, and you can see the little patches of gas and dust that give that sort of texture. Now, explaining this image in words is one thing, but really we get so much information by looking at an image like this. So how can we translate this into something that's accessible for people who can't look at the image the same way that everybody else can? So the basic idea we came up with was to take a normal telescope image, we feed it through a 3D modeling program that looks at the brightness of each of the image pixels. So it takes the pixels that are closest to white, or the brightest pixels, and raises them up. It takes the darkest pixels, or the pixels that are closest to black, and it lowers them. And then it scales the height of every other pixel in between, depending on how bright or how dark those pixels are. And so what we end up with is a height map, so a tactile analog of a visible image. And the idea is that people can run their hands across this, they can run their fingertips across this, and they can feel all of that detail that you would be able to see if you were to look at a tactile image. So they can feel the bits that are brighter, the bits that are dimmer. They can feel the shapes of these images. They can get all of that information that would be really visual, but using their fingertips instead. So we knew that we'd come up with a really good idea. And during the 2016 pilot that we ran, we realized that it was really important to get the help of our local vision impaired community. So we actually ran a lot of test sessions where we took our resources, or the resources that we were developing, out, and we talked to people about them. We talked to people with all different kinds of vision impairments, and we got their individual feedback on what they thought worked really well, what they thought didn't work particularly well about our models, but also about the way that we explained the models to these people with varying degrees of vision or no vision at all. We also produced a lot of different variations of these models to try to work out what would work best for the majority of people. So we produced models of different sizes. We produced models with different tactile heights to try to work out where people were able to feel the most detail, where they would stop feeling detail, and where the detail would be too sharp and too unpleasant to touch with their fingertips. So all of this interaction with our local vision impaired community was so important to making sure that these models worked really, really well. And these resulted in the final models that we have today. These models have a lot of additional features that also came out of that consultancy with the local vision impaired people. So one of the things we added later was, if we, so our images obviously have tactile features on one side. If we flip them over though, we've basically taken the original telescope image, the black and white image, we've mirrored that and we've attached it to the back of the model. So for users with some vision who can see a little bit, so like myself, we can look at that telescope image and we can touch the tactile features corresponding to that on the other side. And so we can combine our sense of touch and our sense of sight, whatever amount of sight we have. And so it's a way of making sure that people can use whatever senses they have to their advantage. They're not just stuck using their eyes, or they're not just stuck using their fingertips. They can use a combination of the two if they want to. The other thing that came out of discussions with vision impaired people was, you may notice that there's a raised border around the edge of the tactile image. This border is the same height as the maximum sort of height of the tactile features in the image. So it's a way for people to work out how bright any part of the image is. They can bridge their hand from the edge to the center, from the edge to any of the features, and they can work out how tall that feature is compared to the maximum. So it's sort of a way of gauging, I guess, the brightness of different parts of the image. So all of this stuff is stuff that came out of discussions with other vision impaired people. We had the original idea, but it would never have been fleshed out or improved on as much as it was if we hadn't have worked with our local vision impaired community. So I think that's a real takeaway message, is that we can come up with great ideas for engaging with diverse communities, but unless we actually work with those communities to develop those ideas further, oftentimes we end up developing things that don't actually work that well. So that's one really important thing to remember. Okay. So in 2018, we were awarded an STFC Nucleus Award. So the STFC is the Science and Technology Facilities Council. It's one of the big funding bodies in the UK. And that allowed us to focus on engagement with schools, so both locally and nationally. It allowed us to produce and distribute these models that we'd created. So actually 3D print these models and send them out to people to use. And it also allowed us to focus on training other people so that they could learn how to use our resources themselves and help us get our resources out to even more people. And I'm going to briefly talk about how we went about doing that. Okay, so for schools, we developed these versatile tactile resources. We basically developed 10 different tactile galaxy images, all based on real images from the Sloan Digital Sky Survey. These images, when used together, can basically, we can use them to talk about all different aspects of research related to galaxies. We can talk about the shapes of galaxies. We can talk about the colors and the stellar content of galaxies. We can talk about the physics that actually make galaxies the shape that they are. So we have examples of merging galaxies. We have examples of spiral galaxies. We have examples of elliptical galaxies. We have all these different morphological stages that galaxies go through. So we can use these to talk about a whole lot of different things. We've also created workshops for older primary school students and younger secondary school students using these resources. So workshops that can basically run for an hour in a classroom, in a school, that anybody in the classroom can use. And the idea here is that we would normally be engaging with classrooms that have maybe 1 or 2 vision impaired students, but the majority of the students in that classroom are perfectly sighted, so they can see perfectly well. The idea is, though, that in that classroom, everybody will be working together using the same accessible resources, learning in the same way at the same time. Because oftentimes in these kinds of classrooms, if there's only 1 or 2 vision impaired students, they can sometimes feel like they're isolated. They can be off to the side, doing their own thing, separate from everybody else. And so the real strength of these kinds of workshops is that it brings everybody together and it puts everybody on equal ground. So everyone's using the same thing to learn at the same time. And based on feedback from students and teachers, we've actually found that this has improved the confidence of vision impaired students. It's helped them to engage with the rest of their classroom in situations where sometimes they would have been a little hesitant to engage with the other students. But basically, it's just brought everybody together, and it's helped a lot of the fully sighted students understand what the vision impaired students need to do to learn about the same kind of stuff that they learn about. And lastly, we've also put together supporting documentation for all of this. And the idea there is that teachers or science communicators can use that documentation to teach themselves how to use these resources effectively with their students or in classrooms. And here I've got 2 pictures of us working with some students in a local school. So these students actually helped us develop these workshops. So we worked with them over the course of about 8 or 9 hours, discussing ways that we could describe these images in ways that were less visual, talking about ways that we could describe the physics going on inside these galaxies in a way that was accessible to them as well. So they really helped us with their feedback, put these workshops together. It was really, really helpful. So I'd mentioned at the start that one of our main goals was to try and help other groups, so other science communicators, other researchers, work out how to make what they're doing more accessible. And so along the way, we've done a lot of that kind of work as well. We've worked with science centres on various exhibits around the UK and internationally. So we've helped them make tactile resources and other things that they can use to communicate science in different ways. We've helped international groups like the AstroBVI project in South America, which has done something quite similar to us. They've used some of our tactile images to train up teachers in many countries in South America to help engage with local vision impaired communities. We've also worked with other international organizations like the iData project in the US, which is working on an accessible suite that'll work with robotic telescopes so that people with vision impairments can use that to take observations and then listen to the observations. We've also worked with organizations like the British Science Festival. So we've tried to help as many groups as we can adapt what they're doing, make it more accessible. We've had a lot of fun doing that. So this is an example of one of the exhibits we helped with. This is the Museum for Life in Newcastle in the UK. They wanted to make a giant tactile image of the Milky Way based on the really famous Gaia image that's been taken by the European Southern Observatory. And so this is a massive tactile image that people can basically walk past and feel. We understand that's being used by a lot of people. A lot of people are getting a lot out of that. What they're actually finding as well is that even people with perfect vision are getting something out of this, because touching an image is such a novel experience that it actually really draws people in. It engages people in a really different kind of way. We've also run workshops to talk about ways to make astronomy more accessible. So on the left is a workshop we ran at the CAP conference, so the Communicating Astronomy to the Public in Tokyo a few years ago. On the right is a presentation that we gave at a Presenters Network conference in the UK, where we talked about some of the common mistakes people make when putting scientific or science communication presentations together. So things they do with images or with color contrast or other things like that to make it really, really difficult for people with vision impairments to see, but also things that in the long run just make it easier for everybody in an audience to see a presentation. Back in 2018, we were also involved with the British Science Festival project. So I worked with Dr. Chris Harrison, who was at the time working for ESO, is now working in Newcastle, but he wanted to put together an experience that anybody could take part in that involved these tactile images that I've got pictured here. So you can see we made some extra tactile images of things like the cosmic web, the M87 black hole, some comets. There's all kinds of cool tactile images we made for this, but he paired these up with these amazing sonifications of data. So basically turning data into sound. And so we combine that sound with these tactile images to help people in the audience experience space in a different way. So that was also a really exciting thing to work on. And so lastly, I talked about our goal of helping other people basically learn to use our resources so that we could get our resources out to more people. So at Portsmouth, we're actually quite a small team. So it's really just myself, our technical advisor, Coleman Kruzek, who is the one who wrote the code that makes our models, and our outreach and public engagement officer, Dr. Jen Gupta, who is the one who sort of came up with the ideas for how to, I guess, expand our project, get it out to more people. So there really aren't very many of us working on this. So we wanted to look at ways that we could get more people involved in the project and get our resources out to more people as a result of that. And so in 2019, we ran 5 presenter training workshops in locations across the UK. So we ran workshops in Edinburgh, in Manchester, in Birmingham, in London, and in Portsmouth. These were attended by 66 people in total. So these were everyone from so research astronomers to science communicators, people who worked in museums, at science centers, just interested members of the public who thought that they were really inspired by this project. They wanted to take the resources and engage their local community. So we got people from all walks of life who wanted to learn how to use these resources. And so as well as going over how to use the resources, we also spent a fair bit of time just talking to people about engagement with vision impaired people, because it turned out that a lot of the people who wanted to use these resources to talk to their local vision impaired communities were actually really scared that they were going to say something offensive, or that they were going to use the wrong language, or that they were going to do something wrong, basically. And so a lot of the work we did during these workshops was actually reassuring people that they weren't going to offend people, that they could say things like, "Oh, I see what you mean," and not offend people with vision impairments. So that was a really important part of this process as well. And so after we trained these people, we then put out a call for applications. so that we could send out resources, so actual physical resources to these groups so that they could start delivering the project to their local communities. So we created 20 resource kits. We sent these out to 20 different groups around the UK. And before the pandemic hit, they just some of those groups had just started to do work with their local communities. But obviously, the pandemic has sort of put a bit of a stop to that side of the project. We are really hoping, though, that once we can start getting back into schools, once restrictions lift, once it's safe to start using tactile resources with large numbers of people again, that the project will pick up steam again and start engaging with more people again. Lastly, we also made our resources available online for free. So we wanted to make sure that anybody with a 3D printer anywhere in the world could access the resources and 3D print them themselves. And so we've had a large number of people download the resources so far. It's been a little bit difficult to track exactly who's downloaded them and used them for what. But we know, for example, that there are groups in Canada who've downloaded the resources and used them in stargazing nights. So there are people around the world who are downloading the resources and using them for free, which is really, really exciting. And so here I have a picture of one of the workshops that we ran. So on the left-hand side, there's actually a completely blind lady who works for a theatre company. And she was really excited by the project because she's interested in science casually, but she was really interested in seeing whether there was a way for her to combine her experience with theatre with a way for sort of communicating astronomy using these resources. And so in this picture, she's actually talking to all of the other people around her about what she can feel, and she's describing it in the language that works for her. So even though she's only just picked up these resources, she's already teaching all of the other people around her based on her sort of current experience with the resources. On the left here, I've got a picture of some of the models that we made. So the resources we produced during this period to send out to people, we actually experimented with using liquid resin to basically cast the images rather than printing them using a 3D printer. And so you can see on the table, there's an array of about 400 tactile images that we produced to go into these 20 kits. And on the right, there are the 20 resource kits. So these contained everything that these groups would need to basically run these workshops with primary school students and with secondary school students. And so one of my colleagues actually hopped into a van and drove these resource kits all around the country to drop them off to the people who'd been awarded them. And so, as I said, just before the pandemic hit, some of the groups that we'd sent our resources out to had just started to engage with their local communities. They were having really, really positive experiences, and the students working with them, so the students that they were engaging with, were also having really positive experiences. And you can see on the right-hand side, there are some thank you notes that one of our colleagues was sent after they ran a workshop with these students. And they were really inspired by space after using these resources, because they felt like it was something they could actually access, that they could be a part of. So lastly, we've obviously built up this network of people around the UK using our resources, but it's really important to us to keep supporting that network and to make sure that they have everything they need to keep reaching the local vision impaired communities around them, and to keep using the resources that we provided them with. So again, this is something we were doing just before the pandemic hit. We're hoping to pick this up again once the pandemic is over, once restrictions are over. What we want to be able to do is hold regular meetings with anybody who's using our resources to address any issues they might be having, any problems they might have come across while delivering the resources. And basically just be there to support them. So just form this group of people who are using our resources, make sure that everybody is supporting everyone else and giving everyone else the help that they might need, just to make sure these resources are being used effectively. We're also working on some shared evaluation that everybody using the resources will be able to use when they visit schools or when they use the resources with their local communities. What we want to use this evaluation to do is hopefully put together a case study. So we want to write up a case study that we can publish in a journal that talks about the effectiveness of these resources and where we might still need to work on improving the way we deliver astronomy to the vision impaired public. But we think this is going to be a really important step in helping other groups look at ways that they can improve the way that they're communicating their science to other people. We're also in the process of developing shared FAQ documents and other sort of general information documents that anybody using our resources can add to based on their experiences using these, while they're delivering the resources to their local communities. So looking to the future, obviously we've achieved a lot so far, but there's still a lot of work to do. So in 2020, we were awarded an STFC Legacy Award, which is basically a follow-on to the Nucleus Award. The idea is that we want to make sure that even if we can only work on the Tactile Universe for the next couple of years, that the project will keep going without us. So what that will involve is that we want to develop one more set of resources that we can use to engage students in upper secondary school. So students getting towards the end of their secondary school education, getting ready to go to university. And for those resources, we want to focus on gravitational waves. And we don't just want to focus on tactile resources, we also want to start including some audio resources as well. Because we feel like gravitational waves, there's already a precedent for sort of audio communication. I don't know whether any of you remember the original press release for the first detection of gravitational waves. They played that chirp sound, so that sound of the gravitational wave detected, that had sort of been, the frequency had been shifted so that it was audible, but it was the sound of that gravitational wave going off. So there's already a little bit of work that's been done turning gravitational wave science, adapting that into different formats. So using audio, using tactile. And so we hope to be able to develop some resources that we can use to engage older students, as well as the existing resources we have. We also, this time around, want to target research groups who are actually studying gravitational waves. So we want to go to the LIGO groups around the UK, so in Cardiff, in Birmingham, and in Glasgow, as well as our local group at the University of Portsmouth, and train those researchers in how to use these new resources so that they can be the ones who go out into the community and work with vision impaired people. Because as actual researchers, they can be really strong role models for the people that they work with. We also want to make sure that we continue to maintain that network of people who are already using our resources, that we provide additional training if they've forgotten basically how to use our resources because it's been such a long time. We want to be able to refresh them, so make sure that they have all the information they need to keep going. And we also want to introduce these new people from LIGO into that network as well, so that they can draw on the experience that's being collected there. And so finally, I guess I'll leave you with this last slide. So I mentioned a lot that we have resources that we've made available online for free. If you go to www.tactileuniverse.org, that website has all the information about our project. It's got links to all of the resources, so the 3D printable files, these schools workshops that we've put together, the FAQ documents, all the information you need to use these resources is there. You can also follow us on Twitter at Tactile Universe. And if you ever need to get in touch with us about anything, if you decide you want to use our resources, if you want to use the code that we use to make our 3D images, which is also available for free, you can also email us to ask us questions about that. But you can email us at tactileuniverse@gmail.com. We're always happy to help and to be there to answer any questions anybody might have. And I've probably gone a little bit fast there, but I'm absolutely happy to take as many questions as there might be now.
Thank you very much, Nic, for a great talk and thoroughly enjoyable and informative. If anyone has any questions, you can feel free now to unmute yourself and ask, or raise your hand and I will call on you, or type it in the chat and I will read it out for you. I see, Thijs, you've raised your hand.
Yes, I saw in the examples you showed, I believe most of those were taking the brightness of an image and turning it into a height for the tactile model. Have you tried experimenting with other parameters like color, for instance, for those galaxies?
So color is actually tied into the way we deal with the images. So in the SDSS survey, there's a U-band filter that they use for the telescopes and an I-band filter. So the U-band is sort of far blue, so not quite ultraviolet, but the far end of blue. And the I is the far end of red. So not quite infrared, but near infrared. And so all of the galaxy images we've produced use both of those color filter images. So we have one image that emphasizes the blue features in the galaxy. The other image emphasizes the red features. And so particularly in the spiral galaxies, there's a massive difference between, I guess, these red and these blue images. So the arms really pop out in the U-band filter, whereas the core and sort of the more dispersed starlight, I guess, really shows up in the I-band images. So yeah, we are dealing with brightness primarily, but we are also dealing with color because obviously to produce a tactile image of a full color image, you lose so much of the information that's conveyed in the visual image unless you break it up into those individual filter images. But I guess the nice thing about doing it that way is that we're sort of treating the data the same way that astronomers do. So astronomers don't really look at full color images very often, right? We look at these images taken with individual telescope filters. And that's how we do our research. So to actually use those images in the way that we talk about galaxies is a really, really good way of tying it to the science and the way that astronomers actually do this kind of research. I don't know whether that answers your question or not.
Yes, it does. Thank you.
But also, I mean, so one thing we haven't really tried yet, but obviously there are other applications here. So say if you had a radio image of a galaxy and you wanted to compare that to the optical image of a galaxy, you could very easily use, say, a density map, turn that into a tactile image, and then you could have the comparison of the optical image on top of that as well. So there's definitely scope to sort of look outside the visible spectrum for these images as well.
Yeah. Martijn.
Yes, my question is a bit of a tangent and a bit self-serving, but do you know about the possibility to observe with a telescope for specific types of visual impairments?
So it's definitely, I mean, the fact that everything's digitized now makes it so much easier. So I know in my case, data that I've taken on telescopes in the past, because most of that is done through an interface. So you're not actually physically looking through the telescope anymore. Everything is digital. It's a little bit easier. Also, the fact that the images that are produced are digital means that for somebody with low vision like me, I can change the contrast. I can choose whatever colors I want. I can do a lot of things to that image to make it easier for me to see. Having said that, though, it is still very difficult for people with no vision to sort of process, I guess, images that have been taken with telescopes. And so that's where projects like iData come in. So iData uses something called Afterglow Access, which is, it's an educational program that's attached to a robotic telescope network. The idea is, though, that they've basically worked out a way to scan across an image and play musical notes depending on the brightness of the different pixels of the image. So it scans in a straight line across the image. It's kind of, I'm not doing a very good job of explaining it, but it's sort of a step in the right direction for people with no vision at all to be able to actually start to analyze images that have been taken by a telescope, even if they have no vision at all. So there are definitely ways of doing that. Obviously, with these tactile images, that's another way. The only downside of that, of course, is that these images take about 8 hours to 3D print. So there's a delay. You can't just observe and then produce a tactile image straight away. There's a bit of a gap between, that process, I guess.
Okay, thank you. But so the context for this was that I'm an organizer for an astronomy camp.
Okay. Yeah.
And we might have a participant who is vision impaired, but I'm sorry, I'm unfamiliar with the language about this, but like mild, like he can go to a regular school.
Okay. Yep.
And I'm just trying to figure out whether there is a possibility that with his specific visual impairments, you will be able to also look through one of the telescopes that we have,
Okay.
because we do also observe at night.
Yep. So, I mean, it really is going to be, the problem with this is it's so individual. So I think what you can do is approach this as a we'll see how it works kind of situation. So what you'll need to do is communicate with that student and explain what's going on, ask them what they think they'll be able to do. If they say, no, I won't be able to see anything, then yeah, you need to think of something else, I guess. If they want to try, then absolutely let them try. One other thing that you could possibly do is if you knew what you were going to be pointing your telescopes at as part of the camp, you could make some tactile images beforehand and present those as a way of sort of saying, so this is what everybody is looking at through the telescopes, if that makes any sense.
Okay, thank you. I will think about that.
Yep. But yeah, if you, like I said, though, if you wanted to make those images, if you want help producing those images, please get in touch and we can help with that. We can't 3D print them for you, but I can make the digital models to send to you, and then you could 3D print them.
Yeah, that would be great. I've already found a person who has a 3D printer and is involved there. So yes, thank you.
No worries.
Great. Any further questions? I'm sure there will be some. I have a question about if you've got any strategies or seen any effective strategies through the COVID lockdown about how to maintain some level of accessibility for tactile learning.
Yeah, so it's been really, really tricky. If we had more resources, I think what we would have tried to do was probably produce individual kits and send them out to actual schools. We would have had to be very careful, though. Obviously, we would have had to sanitize the models first. But yeah, so what we have done a little bit of, we've spoken to, so there have been a few vision impaired students around the UK who've gotten in touch because they've heard about the project. They're students who are already interested in astronomy. And so we've been able to talk to them about what it's like being a vision impaired person doing astronomy. And we've sort of tried to set up future engagement with those people in their schools, I guess. But no, to be honest, the pandemic has been quite difficult. Obviously, using platforms like Zoom and Microsoft Teams and all these other things that we've become really used to using, none of these have been particularly easy for people with vision impairments to use. So yeah, it's been difficult.
Yeah. I think even in normal times we have difficulties with that too. I have one of my students is here who's currently working on a model making kit for introduction astronomy, and because even in a physical classroom, we tend to be standing at the front of the room if we're showing people a model, and like I'm holding up a model, and even the non-visually impaired learners have still never got to touch this model or really see it up close. So I think there's that distribution problem. Yeah,
definitely. I mean, 3D printing's good in that it's relatively inexpensive. I mean, the biggest cost is actually getting the 3D printer itself. But once you have one, the actual plastic that you use to make the models is quite inexpensive. It's just, I think time ends up being the most expensive thing because, yeah, it's sort of 5 to 8 hours to print a single tactile image. And yeah, but in the next couple of years, actually, it's quite exciting. There are groups in the US and I think in Europe as well who are developing tactile tablets that basically can display images almost in real time using the same basic idea that we've used to make these models. So they provide a way of showing these images really, really quickly, basically, rather than having to 3D print everything individually. Yeah.
Great. I'm excited for that too.
Yeah.
Any further questions from anybody else in the audience? You can raise your hand or just unmute and ask. I should check the chat as well. Okay, well, thank you very much, Nic, for that great talk. I think it's given people a lot of ideas about working on that, certainly me. You might be able to hear my 3D printer quietly rumbling in the background. Printing a model of Vesta right now. We had some students observing that the other night, so
nice.
They're going to have a model to play with too.
Yep.
So yeah, thank you very much for coming and joining, and I hope that you'll get some more contacts and collaborations out of this as well.
Absolutely. No, like I said, if anyone wants to reach out, please do, because we're always happy to talk about the project or help anybody who wants to make their own tactile images using our code or print the images that we've already made. So always more than happy to help.
Thank you, and thanks once again.
Thank you.
And
thank you very much.
Yeah, thanks.
Thank you, Nic. It was very interesting.
you.
And thank you, Jake, for organizing.
Thank you very much.